All right, algebra students, it is the moment you have all been waiting for, the quadratic formula. The quadratic formula can be used to solve any quadratic equation of the form ax squared plus bx plus c equals 0. So if your quadratic equation is already in standard form, you can identify a, b, and c and plug them into the formula. If your quadratic equation is not in standard form, if it's not equal to 0, if you've got something else going on, convert it to standard form before applying the quadratic formula. So first, get it into standard form. And this will work for every single quadratic equation that you're trying to solve. Second, you're going to identify a, the letter in front of the variable squared, b, whatever's being multiplied by the variable, and c, your constant. And then this is the formula that will enable you to find the solutions. I'm going to sing it for you because that's the best way to memorize it. I'd also recommend that you write this down. So find a pen and paper, find somewhere to write, and I'll go ahead and show you the song. So here's how it works. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll do it one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So say we wanted to solve the equation 2x squared minus 3x minus 5 equals 0. I would identify that a is equal to 2, b is equal to negative 3, and c is equal to negative 5. And then I would simply plug in. X equals the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 5 all over 2 times 2. So we're plugging in 2 for A, we're plugging in negative 3 for B, and we're plugging in negative 5 for C. So the opposite of negative 3 is a positive 3. Negative 3 squared is 9. 4 times 2 times negative 5 is going to be a negative 40. And then 2 times 2, of course, is just 4. 9 minus negative 40 is 9 plus 40, which is a positive 49. The square root of 49 happens to be 7. So I can take 3 plus 7 and get 10 over 4. Or I can take 3 minus 7 and get negative 4 over 4. 10 over 4, of course, simplifies to 5 halves. And then negative 4 over 4 would simplify to negative 1. So I'm just plugging in A, 2, B, negative 3, and C, negative 5 into the quadratic formula. Same idea for this second example. So with this second example, the key difference is going to be that I have an equation that's not currently in standard form. I have 9n squared is equal to 4 plus 7n. So the first thing that I would want to do is I'd want to subtract the 4 from both sides. And that would give me 9n squared minus 4, and then on the left side it would cancel and I would just be left with 7n. And then I would want to subtract the 7n from both sides with the goal of getting 0 on the right side. So my goal here is to get standard form. So I would have 9n squared minus 7n minus 4 on the left side. And then on the right side, I would have all of that is equal to 0. So if that was a lot to follow, the goal here, the key thing to notice is that you're subtracting 4 from both sides, and then you're subtracting 7n from both sides, and the reason we're doing those two steps is to convert this equation into standard form. Once it's in standard form, I am then able to identify A, B, and C. So a is 9, the number in front of n squared. B is -7, the number in front of n. And then c would be -4, the constant at the end. I'm just going to go ahead and paste the quadratic formula right here so you can see it super clearly before we plug in. So I'm just going to plug in -7 for b. So negative b would be the opposite of -7, which of course is equal to +7. B squared would be a -7 squared, which is better known as 49. 4 minus 4ac, so 4 times 9 times -4. That's going to be a -144, so I'm going to take 49 minus a -144, and then 2 times 9, of course, is 18. That gives me 7, plus or minus the square root of 49 plus 144, which is 193, all over 18. In both of these examples, B and C happened to be negative. A was positive, but B and C were negative, which gave me a +7 here, and subtracting a negative here. There will be other examples. You know, if B is positive, of course, this would be negative because it would be -B. And then if A and C are either both positive or both negative, you'd be subtracting a positive instead of subtracting a negative. So just because it showed up that way this time and last time doesn't mean it will always be the case. The key thing to remember is this formula and how to identify A, B, and C. So make sure that you have a quadratic equation that's in standard form. Convert it to standard form if you need to. Plug into the formula and simplify. Let me know if you have any questions, and good luck.